In this chapter, we're going to be dealing at the logic level of abstraction and show how to build circuits using Boolean algebra and logic gates that we talked about in chapter 1. So we'll talk about combinational circuits, Boolean equations, Boolean algebra, how to go from these Boolean equations to gates, and we'll talk about some other methods such as Carnot maps for dealing with Boolean equations, different logic levels or output values, and then talk about combinational building blocks and timing. So a logic circuit is composed of inputs, outputs, some functional specification, and timing specification. We'll start by talking about these three. So we have some inputs like A and B, one or more outputs like Y, and what this thing does. So for example, an AND gate, here's its inputs, its outputs, and its function is it performs the AND operation. And we'll talk about timing specifications at the end of this chapter. So here is a logic circuit. So each circuit, so here's one circuit, can be composed of subcircuits, so element 1, element 2, and element 3. We have some inputs. Here are inputs, A, B, and C. We have some outputs, Y and Z, and we may also have nodes that are internal nodes that are neither inputs or outputs. So in this case, we have one internal node and one. And they can be composed, this larger circuit can be composed of subcircuits E1, E2, and E3, which themselves are also circuits. Combinational logic, which we're talking about in this chapter, is memoryless. That is, the outputs are completely determined by whatever the current value of the input is. So they don't remember, oh, what was my last input? No idea. It's completely determined by what the current inputs are. Sequential logic, which we'll talk about in chapter 3, does have memory, where the outputs are determined by not only the current values, but also the previous values. And so in this chapter, chapter 2, we're focusing on combinational logic. So we have rules for building combinational circuits. First one is that everything that we use to build the combinational circuit has to be combinational. So in other words, the output has to be completely determined by the current value of the inputs. Second rule is that every node is either an input or connects to exactly one output. So we couldn't do something like this, where we have this output connected to two outputs of gates. And the circuit can contain no cyclic path. So for example, this would not be a combinational circuit because it has a cyclic path where an output feeds back to the input of that same circuit.